Welcome to the International Code Council's overview of changes to the 2012 International Plumbing, Mechanical, and Fuel Gas Codes. My name is Lee Clifton, Director of Plumbing Programs, and here also with me is Bob Gunther, Director of Mechanical Programs. The opinions expressed in this presentation are those of Bob Gunther and myself, and do not necessarily represent the official position of the ICC. This program is designed to provide a general overview of the notable changes that occurred between the 2009 and 2012 editions of the International Plumbing, Mechanical, and Fuel Gas Codes. It is intended to acquaint users of the PMG codes with some of those provisions that have been added, modified, or clarified with the previous edition. Only a limited number of changes will be addressed today. This presentation will provide you with a preview of the changes that have taken place in the 2012 editions of the International Plumbing Code, International Mechanical Code, and International Fuel Gas Code. New provisions, deleted provisions, changed provisions. The 2012 Significant Change Seminars are available now. Our new publication on the significant changes to the 2012 International Plumbing, Mechanical, and Fuel Gas Codes are available right now. The purpose of this publication is to familiarize plumbing and mechanical officials, building officials, fire officials, plans examiners, inspectors, design professionals, contractors, and others in the construction industry with many of the important changes that have taken place in the 2012 IPC, IMC, and IFGC. Throughout this book, each change is accompanied by a photograph, an application example, or an illustration to assist and enhance the reader's understanding of a specific change. A summary and discussion of the significance of the changes are also provided. Each code change is identified by the type, be it an addition, modification, clarification, or deletion. To help you follow along, we have provided an icon that identifies the types of changes. It will be placed to the left of the summary. The following symbols represent the different types of changes. Internationally, code officials recognize the need for a modern, up-to-date plumbing code addressing the design and the installation of plumbing systems through requirements emphasizing performance. The International Plumbing Code in the 2012 edition is designed to meet these needs through model code regulations that safeguard the public health and safety in all communities, large and small. Let's take a look at just a few of the changes that have taken place. In Chapter 2, the definitions of grease interceptor has been modified for consistency with current industry terms for the two general types of grease interceptors being used in plumbing installations. The provisions of Section 1003.3.4 addressing grease interceptors and automatic grease removal devices were never intended to apply to gravity grease interceptors. The new terminology now makes a clear distinction between the two types of grease interceptors, hydromechanical and gravity. The revision to the definition, along with the changes made in Section 1003.3.4, place the IPC in better alignment with product standards and industry terminology. Both types of grease interceptors require diligent effort by restaurant facility managers and staff to ensure that they are regularly maintained and properly serviced. For a grease collection device to work correctly, it must be properly designed, installed, maintained, and serviced regularly. The identification requirements for plumbing products and materials have been clarified. The modification to the identification and provisions of Section 303.1 clarifies the intent of the code that products and materials shall bear the identification of the manufacturer as well as identification requirements that are referenced by the applicable standard. As a result of the modifications made to Section 303.4, all plumbing products and materials must now be listed by a third-party certification agency. Table 303.4 was deleted as a result of the modifications made to Section 303.4. 403.2 Separate toilet facilities and Group N occupancies. The exemption from separate plumbing facilities for each sex in Group N mercantile occupancies now applies where the occupant load of the occupancy does not exceed 100. Recent years have seen an increase in mixed-use buildings that are predominantly residential in use, with one or more small secondary retail components. Such retail spaces are quite often developed into neighborhood retail that is boutique in nature and classified as a group in occupancy. A study by the U.S. Department of Labor, Bureau of Labor Statistics, indicated that the typical floor area of the retail units fell within a range of 1,500 square feet to 3,000 square feet. As an example, based on the International Building Code, Table 1004.1.1, at 30 square feet per occupant, a typical space of 24,000 square feet would have an occupant load of 80 persons. Consequently, such a space did not previously qualify for Exception 3 of the IPC Section 403.5 that allows for a single toilet facility to serve up to 50 occupants. Therefore, the space would have required separate toilet facilities for males and females. The requirement for separate facilities for each sex placed on these smaller retail occupancies often led to manipulation of the occupant load calculation for the purpose of avoiding the additional toilet facility. Because a Group M occupancy requires a second exit where the occupant load exceeds 49, the manipulation of the occupant load subsequently adversely impacted the means of egress requirements for the space. By increasing the occupant load threshold to 100 persons, separate toilet facilities for each sex are not required for those small retail spaces, having floor areas not greater than 3,000 square feet. Two accessible single-user toilet facilities occupy approximately 80 square feet of floor area, and a 1,500 square foot tenant space. These facilities would occupy more than 5% of the total space. The increase in the occupant load threshold now allows for the industry norm in boutique retail tenant size to be accommodated with one single-user toilet facility, given that it is rare that these small retail spaces be occupied by the number of persons equal to the design occupant load, and that the IPC Table 403.1 indicates that 2 water closets are permitted to serve up to 1,000 persons. The provision of a single toilet facility appears to be more than adequate for the size of space that the proposed occupant load threshold increase would allow. The limited floor area of 3,000 square feet that the proposed occupant load threshold can accommodate is such that neither a 500 nor 300-foot travel distance limitation as required in IPC Section 403.3 would ever be exceeded. Where drinking fountains are required, the permitted locations of the fountains have been specified regarding their placement in multi-tenant facilities, similar to the permitted locations for required public toilet facilities. The sharing of public restroom facilities in multi-tenant facilities has historically been permitted under Section 403.3 of the IPC, but the Code was silent on the sharing of drinking fountains. The new provision recognizes that if employees and the public can share public restroom facilities, then they should be able to also share drinking fountains if located within a reasonable distance. The travel distance restriction of 500-foot maximum between public drinking fountains and the most remote location in the tenant space, as well as the limitation requiring placement of the fountain not more than 1 story above or below the tenant space, is almost identical to the language used in Section 403.3.2 for toilet facilities. The limiting distance of 300 feet in covered mall buildings is the same distance required for toilet facilities. In Section 504.7, it has been clarified that drain pans are only required for storage tank water heaters or hot water storage tanks. Previously, it was unclear whether or not a tankless type water heater needs to be provided with a pan. A tankless water heater does not have a storage tank and thus does not present any greater risk of water leakage than piping in a water distribution system that has been installed and pressure tested in accordance with the code. As a result, the provisions was revised to make the pan requirements specific to only storage tank water heaters and hot water storage tanks. Section 606.7 was added and states that water distribution piping that is installed in bundles must now be labeled for content and direction of flow. Piping in bundles has been known to cause confusion as to the determination of the contents of the individual pipes. Tracing them back to the source is often difficult and time-consuming. Marking bundled piping with the identification of the contents and the direction of flow will help eliminate the possibility of a cross-connection occurring. When repairing or renovating this type of plumbing system, the interval of the identification is also crucial in the proper identification of the piping. Section 704.3 and 711.2.1 was modified. Horizontal branches are now permitted to connect at any point in a stack above or below a horizontal offset. In addition, horizontal branches are now allowed to connect to the base of the stacks at a point located not less than 10 times the diameter of the drainage stack downstream from the stack. As a result of the deletion of Section 711.2, horizontal branches can now connect at any point in a stack above or below a horizontal offset. Research has shown that the turbulent flow in the horizontal offset occurs within the first 10 pipe stack diameters, downstream from the stack. This is the same condition that occurs in a building drain downstream of the base of the stack. At this point, the flow in the horizontal pipe becomes non-turbulent open channel flow. Any connection downstream of where turbulent action is known to occur is now permitted because the concerns for avoiding connections in a turbulent zone are identical. The allowance for horizontal connections to a horizontal offset now mirrors requirements for connections at the base of the stack. In the determination of backwater valve protection from sewage backflow, the use of the finished floor elevation where the fixtures are installed, rather than the flow level rim of the fixture, provides a new point of reference. In determining protection from backflow, the use of the finished floor elevation where the fixtures are installed provides a new reference point in relationship to the elevation of the next upstream manhole cover. By using the finished floor elevation, a single consistent elevation applies to all fixtures on the floor. A substantial increase in the level of protection from some fixtures, such as lavatories, will be accomplished, though there will be no real increase in the level of protection from a shower pan, floor drain, or floor mop sink. There will be an overall increase in protection from the structure as a whole. The use of the finished floor elevation will eliminate the reliance on the seal between a floor flange and the wax ring of a water closet to maintain a seal in a pressure situation in the direction of flow for which it is not intended. The following changes in Section 802.2 are considered logical and provide consistency with other allowances in the code. The thresholds at which indirect waste piping is required to be trapped have been increased, and an exception has been added to address clear water waste. The graphic you're viewing illustrates that the new exception is fundamental in that traps are unnecessary for clear water waste in an indirect piping system. In the past, indirect waste piping was required to be trapped where it exceeded 24 inches in horizontal developed length, or 48 inches in total developed length. The justification for increased developed lengths without a trap, 30 inches for a horizontal measurement, and 54 inches in total developed length, is based on Section 1002.1, addressing fixture traps, including the allowance of 30 inches center to center for a combination of fixture as permitted in exception number 2. The 54-inch total developed length allowance is simply the 30-inch horizontal length allowance plus the 24-inch vertical distance allowed from a fixture to its trap. The changes are considered logical and provide consistency with other allowances in this code. The single stack vent system method, similar to the Philadelphia stack drainage system, has been added as an acceptable venting system in the IPC. In a single stack vent system, the drainage stack serves as both a single stack drainage and vent system. The drainage stack shall be sized in accordance with Table 917.2. The stacks shall be uniformly sized based on the total connected drainage fixture unit load. The stack vent shall be the same size as the drainage stack. A 3-inch stack shall serve no more than 2 water closets. Now let's take a look at a drawing. The drainage stack and branch piping are considered as vents for the drainage system as a whole. Pipe sizing in a single stack drainage system is larger than in a conventional one. However, a significant cost saving is achieved by the reduction in the vent piping needed. This venting system serves as a viable alternative to the more traditional systems that are being used. The length of trap arms is limited, and the vertical drop from the fixtures is also oversized. Fixture connections that do not meet the requirements for a single stack system must be conventionally vented. Oversized unvented S-traps are the major components of the one-pipe system, instead of the conventionally sized and vented P-traps and fixtures that allow water to run off after the tap is closed to fill the traps with water to maintain the trap seal. The length of the trap arm is limited to reduce any suction buildup, and the stack is oversized to limit the internal air pressure and vacuum buildup. Stacks greater than 2 branch intervals in height are prohibited from receiving the discharge from horizontal branches on the lower 2 floors. The separate stack serving the lower 2 floors is required to connect to the building drain at a distance of not less than 10 pipe diameters downstream from the base of the connection of the single stack vented system. This proven method has been laboratory tested to determine sizing and installation requirements that provide proper venting to the drainage system. Bob Gunther will now take you through some of the significant changes that occurred in the 2012 International Mechanical Code.
This section in the 2012 IMC will require mechanical systems to be maintained in accordance with ASHRAE-ACTIV's ANSI Standard 180. This will require a maintenance inspection for duct systems, air handlers, chillers, water towers, and numerous other components of an HVAC system. The standard also specifies at what intervals these components are to be inspected. Parking garage exhaust systems have been added to the definition of environmental air. This change will allow parking garage exhaust ducts to terminate as stated for environmental air in Section 501.3.1 in the IMC. This code change to Section 401.4 allows air intake openings to be located closer to 10 feet from streets, alleys, parking lots, and loading docks, provided that the air intake is not less than 25 feet vertically above these locations. This code change has also changed how the distance from an air intake opening to a street or public way is determined. The 10-foot distance between an air intake opening and a street or public way is now measured to the closest edge of the street or public way and not to the center line of the street or public way as it was in the previous codes. Previous editions of the IMC have required a grease duct to be sloped toward an approved grease reservoir, but there have never been any provisions to address how a grease reservoir should be constructed. Prescriptive requirements on how to construct a grease reservoir are now established in Section 506.3.7.1. The 7 items listed provide a common sense type of approach to the construction of a grease reservoir. The provisions not only specify how a grease reservoir is to be constructed, but also allow for the installation of a factory-built grease reservoir. Field-applied grease duct enclosure systems are allowed to be used to enclose commercial kitchen grease ducts based on the provisions in Section 506.3.11.2. The listing for such duct enclosure systems specifies that they have been tested for enclosing a grease duct only. Code enforcement personnel have encountered numerous occasions where the enclosure system material has been used as an enclosure around a Type 1 hood that penetrates the ceiling and is required to be enclosed as required for a grease duct in Section 506.3.11 in the IMC. Section 507.10 now clearly states that field-applied grease duct enclosure systems cannot be used to satisfy the requirements for the protection of a Type 1 hood. This code change to Section 602.2.1 has reformatted the 5 exceptions so they are easier to identify by the user of the code. This change also requires that all material within a plenum to be non-combustible or be listed and labeled as having a flame spread index of not more than 25 and a smoke develop index of not more than 50 when tested in accordance with ASTM E84 or UL 723. Air dispersion systems have not been recognized in previous codes. They are now acceptable provided they are listed to UL 2518. The reference to that standard has been added to Chapter 15. The next part of this presentation will cover some of the significant changes that occurred in the 2012 International Fuel Gas Code. Section 308.1 in the IFGC now states that gypsum board, more commonly referred to as drywall, requires reduction in required clearances to combustibles, the same as any other combustible material. This clarifies the misunderstanding that gypsum board is a non-combustible material. A change to Section 404.2 now states that CSST gas piping systems are to be installed in accordance with the terms of their approval, the conditions of listing, the manufacturer's installation instructions, and the provisions of this code. Section 408.4 now has an illustration of a sediment trap to clarify the intended installation. In addition, vented decorative gas appliances for installation in vented fireplaces and gas fireplaces no longer require sediment traps. To contact the PMG Resource Center, please write down the following information. The ICC Code Opinion Service is an exclusive benefit of ICC members. ICC members who need code opinions on any of the international codes may call 1-888-422-7233, extension 338077. To read ICC top membership benefits or to join ICC, call 1-888-422-7233, extension 33804, or visit www.iccsafe.org/membership. This concludes the 2012 IPC, IMC, IFGC overview of changes. Please continue through the next 3 slides for information on related ICC publications and seminars. Complete information on significant changes to the IPC, IMC, IFGC can be found in this ICC publication.